All right, in this video, we're going to introduce functions and their graphs. In particular, we're going to determine if a relation is a function. So a little bit of vocab here for this section. First up, a relation is a set of ordered pairs, usually an x and a y. The domain, which is something we'll be talking about a lot in this course, is the set of all possible input values, which we usually use x for our domain. And the range, on the other hand, is going to be the set of all output values, which is usually the y values. So we'll talk about domain and range throughout the year, but we're really going to talk a lot about domain more so than range. So a relation is a function if each element in the domain has only one corresponding element in the range. To put it easier than that, in other words here, each x-coordinate gets only one y-coordinate. So every x-coordinate for our relation would be unique, would not have more than one y-coordinate with it. So example 1, which of the following describes y as a function of x? For the ones that do, state their domain and range. So here we have negative 2, 1, 1, 3, 1, 4, and 3, 1. Well, if we take a look, 1 is paired up with 3, but also 1 is paired up with 4. So here's an instance where you have an x value that has more than one y value. The 1 has a 3, the 1 also has a 4. So again, because we have a repeated x value here, it's not a function. So x equals 1 has two different y coordinates. One of them's 3, the other's 4. Part B here we have negative 2, 1, 1, 3, 2, 3, and 3, negative 1. So we have negative 2, 1, 2, and 3 as our x-coordinates. Since all the x-coordinates are different, this one is a function. So each input value of x is only one output value going with it, one y value. So our domain are the x-coordinates, negative 2, and 1, and 2, and 3. And the range are going to be all the possible y-coordinates, 1, 3, and negative 1, or in order, negative 1, 1, and 3. So even though we already we have two of these y coordinates of 3, we don't have to list them twice. These are sets. So if you're given an equation which is an infinite number of ordered pairs, you can graph it and use what's known as the vertical line test to determine whether or not a relation is a function. So to do that, graph the equation, and I would strongly urge you to use technology for that. And then draw vertical lines through the graph. So if you're going to actually do that, I'd sketch the graph on paper. Don't, if you're using, graphing calculator, or even sometimes you can use your phone or computer screen, you don't want to draw on it. So draw vertical lines through the graph. And if each vertical line hits the graph only once or not at all, it is a function. So if we can draw vertical lines and each vertical line hits the graph at most only one time, then the relation is a function. So example 2, we're going to determine whether or not each defines y as a function of x. So we have x squared plus y equals 4. Well, if we graph that, we get this blue graph here. And drawing vertical lines through the blue graph, each vertical line is going to hit the blue graph at most one time. So in this case, it passes the vertical line test, which means it is a function. So there aren't any vertical lines that hit it more than once. So because that's the case, it passes the vertical line test. Part B, x squared plus y squared is 4. Here we have a circle. And as we can see, the y-axis itself acts as a vertical line, and it hits it once here and once down here. This scales a little bit off on the axes here, but in any event, we have a vertical line hits it more than once, so therefore it fails the vertical line test. It is not a function. Some values of x have more than one value of y. Part C, we have this blue curve here is called a parabola, and we have a point above the curve. And because this point is above the curve, if we draw a vertical line through the point, not only is it going to hit that point, but it's also going to hit our curve, which means it's going to fail the vertical line test, and this is not a function. So that one instance where you can draw a vertical line through the point, it'll hit the blue graph, and that one vertical line hits it hits it more than once. Once at the point, and a second time on the blue graph, blue part of the graph. All right, part D. Now let's put a hole there below the point. And now if we draw a vertical line, then it'll go through that point that's at about like 1.5 here. But it's this, again, there's a hole in the graph like we saw with some of the graphs from set builder notation and interval notation in that section. So we draw a vertical line. It's going to hit this point that's above the blue part of the graph, but it's not going to hit this part. It's actually going to go pass right through it without hitting it. So it actually only hits the picture, hits that graph and the point that's above the blue part. So this one does pass the vertical line test, which means it is a function. So highly encourage you to use technology to graph when you can. So, all right, that about does it for this video. Thank you for watching, and I'll see you in the next one.